Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend tutoring, honey. Personalized math tutoring is the solution.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about quadratic inequalities. I got some fun to show you today, ladies and gentlemen. Let's start with problem number 1. Here I have the quantity of x minus 7 times the quantity of x plus 3, which is less than or equal to 0. Now this is going to be a quadratic expression here on our left side of our inequality symbol. If you were to multiply this all out together, you would end up with x squared minus 4x minus 21. So this is a quadratic inequality. Now notice that it's already factored for us. That's a good thing, and it's set equal to 0. So on the right side of our inequality here, we have a value of 0. That's the form that you're looking for. Once you have it all factored out and it's set to 0, then what you'll do is you'll take each one of your factors and you're going to find what is called critical values. Critical values. So I'll take each factor. This will be x minus 7. I'll set that equal to 0. I'll have my other factor, x plus 3, and I'll set that equal to 0, and we're finding what is called critical values. Let's go ahead and solve for x in each of these equations. I'll be adding 7 to both sides of my equal sign here. This gives me x equals to 7, and then I'll also subtract 3 in our other equation, and that gives me x equals to negative 3. So thus far, I have two critical values. One is 7, the other one is negative 3. Your next step is to make what is called a sign chart. All right, that's the method that I choose to use when I solve quadratic inequalities. All right, and I'm going to start with a number line here. And on this number line, I'm going to place my two critical values. I know I have a critical value of negative 3, and I also have a critical value of positive 7. Then on the left side here, I'm going to list the factors that I had in my original inequality. I had a factor of x minus 7, and I also had a factor of x plus 3. From there, I'm going to use a test value, a test point. And this test value is going to be a value that is smaller than my lowest critical value. So I need a value less than negative 3. So I'm going to use negative 5. All right, it's arbitrary. You can just make up whatever value you want. But here, I'm using negative 5 as my test value. All right. The next thing I'm going to do is I'm going to show that at negative 3, this second factor will equal to 0. I also know that at positive 7, my first factor will equal to 0. Then I'm going to use my test value, and I'm going to plug that into each one of my factors here on the left. If I plug in negative 5 into the first factor, I would have negative 5 minus 7. Well, that value is negative 12, but more importantly, I end up with a negative result. So I know that as long as I have values that are less than 7 going into this first factor, I'll end up with negative results. All right. Then after that 0, or you can say after I reach 7 on my number line here, I'll end up with positive values that will result from me plugging it into that first factor. Okay. Next, we'll do the same thing to the second factor. So I'm plugging in negative 5 into x plus 3, and I end up with a value of negative 2. More importantly, the end result is negative. So I'm going to keep up with the fact that values that are less than negative 3 when plugged into the second factor will give me a negative result. Very important. After that, there'll be positive values. Okay? So this is what I have thus far. Just going along the number line, showing the signs of the results for each factor that I had in the original inequality. Now, ladies and gentlemen, I want you to pay attention to something right here, and that is the original inequality here. Once it's factored, we have what operation going on with these factors? What operation are these two factors doing to one another? Yeah, that's right. They're multiplying together. Very good. And they're saying that the product of these two factors, once you finish multiplying them, the solutions of the inequality must be less than or equal to 0, meaning negative numbers are going to be a solution to the inequality, and the value of 0 is also a solution to the inequality. So what I'll do here in my sign chart is the following. I will find out the products of these signs here. A negative times a negative is a positive result. I know that the result of a negative times a positive is a negative result, and the product of a positive times a positive is going to be a positive result, like so. Notice, ladies and gentlemen, that It's between -3 and 7 that I'll end up with negative results, which is what I want for my solution. I also want values of 0 as part of the solution. I know that 0 will occur when I plug in -3, and I also know that 0 will occur when I plug in +7. So therefore, I end up with a result of -3 to 7 as my solution, ladies and gentlemen. Just like that. In interval notation, I can clearly write it as bracket -3 to +7 because I'm including the value of -3 and the value of 7 in my result. And that, ladies and gentlemen, is the answer to problem number 1. Just like that. All right, let's look at the next problem here. In our next example, we have problem number 2. We have 3x squared minus 5x is greater than 0. So what I'm going to do in this problem here is, first of all, I want to have everything set to 0. It is. And I want to have this factored, all right? And notice in these two terms here, the 3x squared minus 5x, those two terms share an x. So I'm going to factor out an x. So I can rewrite this as x times 3x minus 5, which is greater than 0. Next, you're going to find your critical values. So what do? You set each factor equal to 0. So I have x equals to 0, and I also have 3x minus 5 equals to 0, and we'll solve for each. Your first equation is already solved for. So over here in the second equation, I'll be adding 5 to both sides. And I'm going to bring down this 3x, which equals to 5, and then I'm going to solve for that. And dividing both sides by 3, we'll end up with x equals to 5/3, just like so. So I now know that at this point, I have two critical values. One is 0, and the other one is 5/3. From there, I'm going to set up my sign chart. That's right, my sign chart. So I have two factors, right? I have x, and I also have 3x minus 5. And I'll have my number line here, just like this, and I'll have two values on there. The first value is going to be 0, the other value will be 5/3, like so. I know that at 0 on the number line that my first factor is going to be 0. I also know that at 5/3 my second factor will be 0. I'm going to choose a test value. This test value, let's say that we'll use the value -1. Okay, keeping it simple. So plugging in -1 here as my test value, if I plug in -1 in for x, then that's a negative value. -1 is negative. So I know that things that are to the left of 0 for that first factor will be negative results. Then after I cross 0, they'll become positive. All right. And so I'll just stretch that out along the sign chart there. Now keep in mind, ladies and gentlemen, my sign chart, these negative signs and the positive signs, these are arbitrary. It's not an exact number of negative or positive signs that you place there. This is just for show, okay? So it's not like I'm making sure that there's exactly 5/3 plus signs in between 0 and 5/3. So you don't have to be concerned about that. We're just showing visually that, hey, to the left of 0 I have negative values, to the right of 0 I have positive values. All right, next we'll try the second factor. If I plug in a -1 into the second factor, that'll be a -8 as a result. So I know that this value is negative until I get to 5/3, and then after that it'll become positive values. Going back to our inequality, we had our factored form of x times 3x minus 5. So I know the operation is multiplication, and I know the results have to be greater than 0. Well, what type of results are greater than 0? Yeah, exactly. Positive results. So therefore, I'm looking for a positive result once these two factors are multiplied together. So let's go back to our sign chart here. Here at my sign chart, I know that a negative times a negative is a positive result. I know that a negative times a positive is a negative result. And I know that a positive times a positive is a positive result. And remember, we're looking for positive results and not 0. Notice that the inequality symbol is greater than 0, not greater than or equal to. So we do not want 0 as part of the solution, which is why when I start shading here, that it will be shaded to the left, but we'll use parentheses at 0 here. Also, at 5/3, it'll be parentheses instead of brackets because we're not including 5/3, and our next positive region is to the right of 5/3. So this is my solution here. In interval notation, you would write it as -infinity to 0 union 5/3 to positive infinity. And this is the answer, ladies and gentlemen. I'm going to go ahead and box that up in red. There you go. All right. So that's the solution. Negative infinity to 0, union 5/3 to positive infinity, because we have a positive region here to the left of 0, and we have a positive region to the right of 5/3. And that's that for problem number 2, ladies and gentlemen. There you have it. Let's move on. Problem number 3, in your face. We have x squared plus 2x minus 3 is greater than or equal to 0. What I have is a quadratic trinomial, so I'm going to attempt to factor it. I do know that there are 2 factors of 3 that will subtract to give me 2, and that's going to be 3 and 1. So factoring this trinomial, you'll end up with x plus 3 times x minus 1, which is greater than or equal to 0. If you're still having a tough time factoring trinomials, please check out our video, Factoring Quadratic Trinomials Part 1. And you can also check out Part 2 and 3 as well. All right? So that should be helpful to you. Now that I have my factored form and it's set to 0, we're going to go ahead and find our critical values, which means we take each factor, set it separately equal to 0, and then solve for it. Alright, so here I'm subtracting 3 to both sides of the equal sign. I'm going to bring down, that's an ugly 3. I'm going to bring down x equals to negative 3, and then I'll be adding 1 to both sides here. Alright, so I end up with x equals to 1. Exactly. These are going to be my critical values. Okay, so I know you like me to circle them, so I'm going to go ahead and circle them for you. Next, I'm going to set up my sign chart. So I have 2 factors, right? My first factor is going to be x plus 3, and my second factor is going to be x minus 1. And I have my number line, and I have my 2 values that I found, and that's going to be negative 3 as well as 1. Okay, we know that at negative 3, our first factor, if plugging in negative 3 into the first factor, you'll end up with 0. Yep. If I plug in positive 1 into the second factor, you'll end up with 0. So next, we'll be finding a test value to use in our sign chart. So I'm going to pick, what do you want to use? Negative 4? Let's use negative 4. All right, let's use negative 4 for our test value. Here we go. So plugging in negative 4 into our first factor, negative 4 plus 3 gives you negative 1. Well, that's a negative result, so I'll put some negative signs here. Then, after 0, those values will end up being positive. So for instance, if I plugged in negative 2 plus 3 is a positive 1, so I know that there are positive results to the right of that 0 there on the sign chart. Next, I'll be plugging in my test value into x minus 1. So negative 4 minus 1, that gives me negative 5. So yep, I end up with negative results to the left of this 0 here. And then after that, you'll end up with positive results. Now, what operation is occurring in our inequality? Multiplication, ladies and gentlemen. These 2 factors are multiplying. So therefore, we're multiplying to end up with a positive result because it says greater than or equal to 0. And we're also looking for where 0 occurs on the sign chart. So here we are. We have a negative times a negative, which is a positive result. We have a positive times a negative, which is a negative result. And we also have a positive times a positive, which is a positive result. Remember, we're looking for positive results here on this number line. Therefore, I know that up until I get to negative 3 and including negative 3, I'll have positive results. So I'll be shading to the left here, just like that. Next, I'm noticing that at positive 1, I have 0, so that's part of the solution, and that my region to the right of 1 is positive, so I will also be shading to the right here, okay? That means that in interval notation, I end up with the following result. I end up with negative infinity to negative 3, bracket, union, bracket, 1, to positive infinity, and that's my interval notation, ladies and gentlemen. That's the answer. I'm going to go ahead and put a box around that. Notice how your interval notation really mimics the number line, okay? So notice that you have your extreme going from negative infinity, and then it goes up to negative 3 using that same bracket there for negative 3. You'll have a union because you have 2 parts that you want to join together, and then we'll have a bracket at positive 1, and we'll be shading to positive infinity, so therefore your interval notation reflects that. All right, let's move on to our next example here, problem number 4. In problem number 4, we have x squared plus 8 less than 6x. The first thing you want to do in this example is subtract 6x to both sides. Why? You want to have your expression set to 0 here in your inequality. So I'm going to rewrite this as x squared minus 6x plus 8 is less than 0. So definitely set your inequality to 0 first. Next, you're going to go ahead and see if you can factor it. I'm looking for two factors of 8 that will add to give me 6. Well, that'll be 4 and 2. So this ends up giving me x minus 4 times x minus 2, which is less than 0, just like that. Next on the agenda, you want to get your critical values. So set each factor equal to 0 and then solve for it. Okay, so I'm adding 4 to both sides here. This gives me x equals to 4, and I'm going to add 2 to our second equation, and this gives me x equals to positive 2. So my critical values thus far are going to be 4 and 2, and that's what I'll be using on my number line. So for the sign chart, I have my two factors, x minus 4, I have my second factor of x minus 2, and I have my number line with the two critical values shown, positive 2 and positive 4. Okay, then I'm going to come up with a test value that's less than 2, so I'm going to use 0. That'll be my test value right there. I do know when I plug in 2 into the second factor, I'll end up with 0. I also know that when I plug in 4 into the first factor, I'll end up with 0 as well. Plugging in my test value of 0 in the first factor, 0 minus 4 is negative 4, which is a negative result. So I'll have negative results until I get to this 0, and then they become positive after that. Plugging in 0 into the second factor, 0 minus 2 is going to be negative 2. That's a negative value, and then they become positive after that. All right, just like so, ladies and gentlemen. From that point, we can go ahead and take a look at our original factored form of the inequality. So the inequality is informing us that the product of these two factors must be less than 0, in other words, negative values. So let's check out our sign chart to see where our negative values occur. A negative times a negative is a positive. Okay, a negative times a positive is a negative result, and a positive times a positive is a positive result. What we want are negative results, ladies and gentlemen. It had to be less than 0, so we want negative results. We don't want it to equal to 0, so that means we'll be using parentheses as far as the critical values are concerned. We're not including 2, we're not including 4, so use parentheses. Using parentheses at 2, because I don't want to include 2, I'm going to shade this region here where I had negative results. And it's going to be up to 4, not including 4. So you end up with a solution that looks like this in interval notation. We'll have parentheses 2 to 4, close parentheses. That's it. Meaning that the solutions can be found between 2 and 4, not including 2 and 4. And that's your answer for problem number 4, ladies and gentlemen. Just like that. Okay, that was problem number 4. Let's check out our next example, problem number 5, okay? In problem number 5, we have the quantity of 4 minus 3x squared is greater than or equal to negative 2. Now, there is something special about this problem that you should recognize. One, you already have a quantity squared on the left side of the equal sign, and your inequality is greater than or equal to a negative value. Because we have the quantity 4 minus 3x squared, the lowest value that you'll ever get out of this is going to be a 0 value. That's it. You'll never have any negative values, and of course you can get positive values because we're squaring it. Remember, a negative times a negative is a positive. Of course, a positive times a positive is a positive result, and if you end up with 0 in this quantity, you'll just end up with a value of 0. So the lowest result that you'll get from this is 0, and of course the highest value will be positive infinity. Bottom line, ladies and gentlemen, whether the result on the left is 0 or positive, it will always be greater than negative 2. Always. So your solution here is all real numbers. Any number, ladies and gentlemen, from negative infinity to positive infinity is a solution to this problem. That's right. There was no need for a sign chart in this problem. Because we have a quantity squared, your lowest value is going to be 0. Most likely you'll end up with a positive result, but either way, whether it's 0 or a positive number, it's going to always be greater than or equal to negative 2. So no matter what number you plug in, you'll have a true statement. So therefore, any number will work, which is why you'll end up with negative infinity to positive infinity as your answer for problem number 5. All right, that was that. Hope you had fun with problem number 5. Let's look at problem number 6. So problem number 6, we have a similar situation. We have a quantity squared, 3x plus 5 raised to the second power, and Your inequality is expecting your value here on the left to be less than or equal to negative 4. Well, two things that we know about quantities that are raised to the second power is that the lowest value you can obtain is 0. The highest value is positive infinity. In other words, there's no way that this left side of the inequality will ever be a negative value. It's not possible. So therefore, since 0 or a positive number are the only results that you can get from the left side of the inequality, is 0 less than or equal to negative 4, ladies and gentlemen? No, it's not. Is a positive value less than or equal to negative 4? Absolutely not. So therefore, this answer here is no solution, ladies and gentlemen. It's the null set. There are no answers to this problem. It's no solution. It's not possible. So that's the answer. And I'm putting a red box around this. So that's it for quadratic inequalities, ladies and gentlemen. You had 6 examples. This is Mr. Witt with Fort Bend Tutoring, FBT. And as always, please rate, comment, and subscribe. Check out our Facebook page. We have many killings weekly, ladies and gentlemen, because our clients kill their test all the time. So check that out, okay, on Facebook. Also, if you're able, please donate to keep these free math tutorials coming your way, ladies and gentlemen. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.